Um, she's very good at being a devil's advocate. All right, so we are on lesson 9-1. We are on our brand new unit. There are only 3 lessons this unit. It goes very fast, and there's not like 8 self-checks this time either. So today's date is Wednesday, February 5th, 2020. There's lots of arguing happening over there. Yeah, so we're talking about tabular rates and integrals. Our objective today, Stego, is to
find the approximate rate from the table and both calculate and interpret total change.
There it is. So there's 3 things that we're doing. Find the approximate rate. So I'll give you an equation of what is the approximate rate. And then next, like if I give you a table, can you interpret and actually calculate what that total change is? So 3 parts of that objective. It's kind of complex. So I'm going to give you a table. I'm just going to say you can make your own question up. Like, okay, I have a table with days and guests. Maybe this is guests attending a really fancy wedding. I have no idea what's happening here. But I know that there's guests, and that's over 27 days. So maybe a 27-day wedding. That does not make sense. Maybe I have to change my problem a little bit. Oh, RSVPs for a wedding. Yeah, there you go. I like it. So let's go ahead and graph this data. Again, we're only able to graph points. We cannot connect those points yet, and generally never. But let's go ahead and graph the points. 0, 0. Where is it? See if you can beat Mr. Sindel. 417. 417 is a little bit beneath 120. 10, 135. 10 and 135 is right there. 1389. 1389. It's going to be basically 190. And then 2202. 2202 is basically 2200 if I'm rounding, slightly above 200. So right about there. And finally 27342. 27342. That jumps almost off the graph right there. So once you have your points graphed, I'll give you guys a few more seconds. Go ahead and look up. Does it look roughly the same as mine? If not, there's a big error that you've made. All right. Still graphing, still graphing, still graphing. Today you will not need your calculators now. This is a maybe I should put a calculator, no calculator in the title. Would that be helpful?
Well, by the time.
Just bring your calculators every single day and you'll be fine. As a general rule of thumb. Okay, so the main thing, write this down. And you're going to be writing over and over again. We don't know what's happening. We don't know. Or you were clueless. Yeah, we don't know what happens between these points. That's the biggest thing to take away from this lesson, the most common mistake. And maybe I should add some exclamation points because maybe you would think, oh, well, I'm constantly increasing. It's increasing. It's increasing. As humans, we try to find the patterns like, oh, it's probably some sort of nice wavy function maybe, or maybe straight lines happening between here and here. No, assume the worst case scenario. Maybe 340 people registered on that first day and then they all canceled. You don't know. Maybe I had a straight rate there, but maybe it went down and everyone canceled and they're like, oh wait, it's still back on, it came back up here. Or maybe it had some weird sine wave to back there. I don't know, weird things happen. Maybe there's like some weird extra slope there. I don't know what's happening in between these points. Go ahead and make up your own story to tell yourself, hey, well maybe I can even have like, I don't know, people from the dead. I can have negative numbers go beneath the t-axis. That doesn't really make sense though. But anything could happen in between these points within the context of the question.
So you just connect the points like however.
Connect the points however you want, as crazily as you can to let yourself remember we don't know what's happening between those points. You can make up your own story. Generally speaking, in this unit, assume the worst case scenario. And that's how it works in mathematics too. Like, unless something has been proven to you, you shouldn't believe it. So, now that you know to not assume things, don't assume what happens in between the points, aside from, yes, you have to go in between here and here. The intermediate value theorem says that the heights between 120 and 0, between this point and this point, I know that one of those heights is hit at least once. That's all the intermediate value theorem says. But it says nothing about up here. It says nothing about down here. It just says, hey, these heights right here, those heights are all touched at least once. That's all IVT says. It doesn't say anything about up here or anything about down here. Let's continue down to approximating g prime of 7. So very similar to the AP test, they'll say, what do you think g prime of 7 is? And you're like, wait a second, g prime? They gave us g. How are we supposed to find g prime? And it's the same formula that we learned all the way back in Unit 1.
What is the formula we learned all the way back in Unit 1?
Let's write it down. The formula that you learned back in Unit 1 was g prime of 7 can be approximated, I'll do an approximation, by whatever is to the left and the right of 7. Where's 7? Where's 7 in the T? Between 4 and 10. Circle both 4 and 10. Between 4 and 10, or maybe you want to put a 7 in between 4 and 10, the numbers that we're going to use are the numbers on the side of 7, so 4 and 10. So I'm going to say g of 10 and g of 4. So I'm going to come down here. G of 10 minus g of 4. All of this divided by, anyone want to take a guess at this? Shout it out. 10, not divided by, but minus 4, exactly. This is your average rate of change formula, all the way back from Unit 1. And then actually you have to calculate what that is. So g of 10, well, g of 10 is g of something is right here. So g of 10 is 135. So I'm going to say this is 135 minus g of 4, that's 117. 117, all divided by 6. And I can just leave that as, what is that going to be? 18 over 6. Okay, yeah, so that's 3. And I'm going to write down my answer down here. 3 guests per day. Units here are important too. You usually get points for units. Generally, if you miss one unit, you miss all the points for A, B, and C type of thing. So why is it guests per day? Someone talk to us. Why are we saying guests per day here?
Because we went okay. That's my best guess. Because we find it like number. Never mind. I give up.
That's one word answer. I'm finding a rate. The G prime. On our speed sheet from last unit, I said, what happens? What are our units for whenever I have a derivative? It should always be a rate, some unit per time. So whenever it's asking what is G prime of something, what is a velocity, there's a bunch of different ways to ask the same question. Our unit should always be for a rate, units per time. All right, so I'll add that to our speed sheet for this unit as well, just repetitive stuff. In the table above, we need to now estimate G prime of 25. You guys should be able to do this now. Do it without looking up. I'm going to be writing it silently up here. What is G prime of 25 approximately? Once I see you looking up and checking your answer, I know that you are done. Everyone is checking their answer. Thumbs up, thumbs down. Did you get it? Woohoo! Nice. All right. 100%. So now we need to evaluate. Okay, so that's the first part of the objective, right? First part of the objective, find the approximate rate of change. Check. Now we're doing the next two. We need to both calculate and interpret total rate of change. Calculate meaning find the mathematical answer, and then interpret meaning they'll say, what does this mean? And you'll have to say the right words for what it means. So first, we're going to evaluate the integral. So again, if I'm taking the integral of the derivative, fundamental theorem of calculus, those cancel each other out. It's technically the second fundamental theorem of calculus, I think. But they cancel each other out. And I'm left with just g. So go ahead and cross out the prime, cross off the integral to let yourself know they cancel each other out. This is going to be equal to the antiderivative of the derivative is just capital G of t. And then because it was a definite integral, I have to say evaluation bar between 0 and 13. And let's actually do that. So I'm plugging in 13 first, so capital G of 13. And then I subtract when I plug in 0, so capital G of 0. All right, and then what is that thing? G of 13, I come back up here, that's 189, so it's going to be 189. G of 0 is 0, so our answer is 189. Okay, units. Claire's saying guests. Anyone want to?
I'd say people, but same thing.
People, guests, geostego? Yeah, it is guests, yeah. This is very similar to Unit 8, where I'm taking, if I'm taking the integral of a rate, it's the total amount, or total change in guests. I have 189 guests, and it's the same exact word, it's the total change. It's the same thing from our last unit. Let me type this out. The total change in guests. Okay, from where to where? From
0 to 36.
from A to B in this case, because if I did this integrals from A to B. So from A to B, and then what are our units? Days. Done. So a lot of repetition here. You know how to do the antiderivative of the derivative. You know that it means total change. The only new thing I'm really teaching you today is don't assume what's happening with the table and how to do an estimation of a rate. All right. Fist of 5, how well can we do our objective today?
That's it?
That's it.
Oh.
Is that a 4? 4, 5, 4, 5. All right.
Wait, can you go down to
Yes.